vocabulary involved with solutions. The vocab I'm going to go over are listed below, and here's how you pronounce them: solute, solvent, dissolve, liquid, solid, aqueous, mixture, solution, saturated, unsaturated, and supersaturated. The focus is on solutions. I have two GIFs here that show the process of a solution forming. On the left, this is a teaspoon of salt dissolving in a cup of water to form a solution of salt water. On the right, this is a Skittle dissolving in water to form a solution of sugar water. And a side note, solutions in chemistry usually deal with liquids, but in a technical sense, solutions can be solids dissolved in solids, liquids dissolved in liquids like we see here, and also it can technically be gases dissolved in other gases. Okay, so there are different types of solutions, but we're going to mainly look at liquid solutions. I have a task for you. Look at each beaker here and try to match which description on the right-hand side best corresponds to each of the beakers. I'll give you a few seconds. So it turns out that the left beaker contains solute particles dissolved in a liquid, and these solute particles exist in an aqueous state. The right beaker contains solute particles in a solid state. Here are some of the essential vocabulary that we should know. Solute is a component that is added to a liquid. Aqueous, it means like water or watery, or dissolved in water. Solid means it's a state of matter where particles tend to be packed closely together. And dissolve, it means to break apart into individual units rather than existing like a clump, like a solid. On this slide, we have 5 different beakers. Everything is the same about them except for the amount of solute dissolved in each. So they have the same amount of water, they're all at the same temperature of water, etc. You can tell from the image that from left to right that there is an increasing amount of solute being dissolved in each beaker of water. I have a task for you. I want you to count the number of dissolved particles and the number of solid particles in each beaker, and then match the numbers that are on the bottom to right here. Please pause the video and start counting. Okay, hopefully this is what you counted for each beaker. We should also notice something here as you are counting this. This is our first key idea. Adding solute to a liquid will cause it to dissolve, but it'll reach a point where it won't dissolve anymore. At this point, any additional solute will stay undissolved as a solid, and it usually sinks to the bottom of the container like we see in beaker D and beaker E. Let's do one more task. I've got these 5 labels up here, and I want you to match it to the beakers from before down below. 3 of them are supposed to be saturated solutions, and 2 of them are supposed to be unsaturated solutions. It isn't as straightforward as you think, so pause the video for a bit to think about this. Did you think it should have been labeled like this? If so, then great. So it turns out that a saturated solution is a solution that has reached the maximum amount of dissolved solute, and an unsaturated solution is a solution that is still able to dissolve more solute. Now you might be thinking, isn't beaker C able to dissolve more solute? Well, it appears like that since there's no solid on the bottom of this beaker. But if you look at beaker D and beaker E, those beakers only have 18 particles dissolved too. So that means that 18 solute particles is the maximum amount of dissolved solute in this case. And therefore, beaker C, which has 18 dissolved solute particles, is technically saturated. Adding more solute to beaker C will cause it to stay in a clump and sink to the bottom. Okay, so beaker C is a saturated solution. I also want to include at this point the definition of a solution. A solution is a mixture that contains solute dissolved in a solvent. A solvent is the bigger component of the solution, so usually it's water. It's usually water. The dissolved substance in a solution is usually very small, so the solute is usually very small, and that's why a solution typically looks uniform or well mixed. Now here's a critical thinking question. If you were handed a beaker containing a clear solution with no solute on the bottom, okay, no solid on the bottom, what simple test can you do to determine whether that solution is a saturated solution or an unsaturated solution? I want you to pause the video and think about this. To answer this, we should already know that adding solute to a liquid will cause it to dissolve, but it'll reach a point where it won't dissolve anymore. This means that if you add solute to an existing solution and it can still dissolve, then that solution is unsaturated. Or, if you add solute to an existing solution and that solute remains undissolved, then the solution is saturated. So, this means that the simple test is to just add solute to that clear solution and see if it dissolves or see if it stays as a solid. That's how you can figure out whether that clear solution is saturated or unsaturated. Here I have a bit of practice for you. I want you to try to use the vocabulary that's in the gray box to describe in a few words what is happening to the GIF on the left. Pause this video and try this, please. Okay, so here's what I've got. The salt is a solute. It is dissolving in the water, which is the solvent. When it is all dissolved, the resulting mixture is called a solution. Dissolved salt is not in a solid state. Rather, it is in an aqueous state. If we are able to dissolve more salt, then the solution is considered unsaturated. If not, then it is saturated. Hopefully, you should know what these words mean by now. Here's one last thing I want to go over. Take a look at what's happening here. Also, this right here. What do you think is happening here? It has something to do with the amount of solute dissolved in each of these containers of solution. So this phenomena you're seeing is what we call supersaturated solutions. A supersaturated solution is a solution where there is actually more solute dissolved than allowable for the solution. What? How is that possible? So you can actually heat up a liquid to forcibly dissolve more stuff into it. Then you cool it down very slowly. And for some reason, sometimes the solute will remain dissolved. Okay. If you disrupt the solution in any way, just swishing a super saturated solution in a container, that's disrupting it. If you do that, that solute that is inside that super saturated solution will crash out. It will crash out of the solution, and that's when it reappears as a solid. Isn't that crazy? Alright, I hope you found this video informative.